Hi dears, this is Raji. In this video, we are going to learn about the electrolysis of sodium chloride. So at the end of this video, you will be able to predict what will be the product obtained at the cathode and at the anode when dilute sodium chloride, concentrated sodium chloride and molten sodium chloride is electrolyzed. Okay, so let's start with the electrolysis of sodium chloride. So first let's learn about the electrolysis of molten sodium chloride. Sodium chloride is an ionic compound. In the solid state, it won't conduct electricity, we said. Okay, so what we need to do, we will have to heat this sodium chloride to 800 degrees Celsius. Okay, so that sodium chloride will be getting converted into molten state. To the molten sodium chloride, we are inserting two electrodes. These electrodes are made up of graphite. What's the reason? This is an inert electrode. We don't want this electrode to participate in electrolytic reaction. So that's the reason we are choosing graphite electrode. This graphite electrode will be connected to the terminals of a battery. We had explained already in the previous videos. Okay, the electrode that is connected to the negative terminal of a battery also will become negative. We call it as cathode. Okay, the electrode that is connected to the positive terminal of a battery also will become positive, and we call it as anode. In order to predict what will be the product obtained at the cathode and at the anode, we will have to first write what all ions are present in the electrolytic solution. Write and find out. In this molten sodium chloride, only two ions are present. What are they? Na plus ion and then Cl minus ion. Na plus ion will be moving towards which electrode? Being positively charged, it will be moving towards the cathode. So write the cathode reaction. What will be the intention of this sodium ion? It will be moving towards the cathode and will be accepting one electron from the cathode and will be getting discharged as sodium metal. Got it? And what will happen to the chloride ion? It will be moving towards the anode. Because anode is positively charged. Okay, so write and find out what will be the reaction that is taking place at the anode. Cl minus ion will be moving towards the anode. It will be giving away one electron to the anode and will be discharged as chlorine atom. But problem is that chlorine cannot exist as such. It will be combining with one more chlorine and will be converted into chlorine gas. Got it? If you are passing electricity through molten sodium chloride, what will be the observation at the cathode? You can find out a deposit of sodium metal at the cathode. And at the anode, what will happen? Greenish yellow gas will be evolved at the anode. You can just memorize that. Got it? So easy. In the same way, we will have to predict the product obtained at the cathode and at the anode whenever a dilute solution of sodium chloride is electrolyzed. So, in order to predict the product of the reaction, what we need to find out first? What all ions are present in the solution, you will have to find out. As it is a sodium chloride solution, sodium ion will be present in that. Chloride ion also will be present in that. But as it is an aqueous solution, in addition to Na plus ion, H plus ion also will be present and OH minus ion also will be present. Okay, in this case, two ions are moving towards the cathode. Sodium ion also, H plus ion also. And here Cl minus ion also, OH minus ion also is moving towards the anode. But the problem is that out of these two, only one can discharge at a time. Okay, it's just like a running race. Only one winner will be there. Okay, so who will be the winner? It depends upon certain factors. Okay, we should understand that. So in the electrolytic solution, more than one cations or more than one anions are present at a time. Only one will be getting a chance to get discharged. And this is known as preferential or selective discharge of ions. It depends upon so many factors like relative position of ions in the electrochemical series. It depends upon the concentration of the ions present in the electrolytic solution, and also it depends upon the nature of electrode also. One by one we will have to learn the entire thing in this chapter. So let's first discuss about the relative position of ions in the electrochemical series. See this picture. What is electrochemical series? It is nothing but a series of ions which are arranged in a particular order. Electrochemical series will be containing more anions and more cations than this, but for class 10 this will be enough. Once when you are coming to class 12, you will have to learn that in detail. So what is the use of this electrochemical series? How can we apply this? For example, whenever we are considering sodium chloride solution in the aqueous state, we said that it contains two cation, Na plus ion and H plus ion, and it contains two anions also, Cl minus ion and then OH minus ions. See the position of these ions in the electrochemical series. This is Na plus ion, and where is H plus? Over here. The ions which are present at the lowest position will be getting more chance to get discharged. So out of Na plus and H plus ion, which ion will be getting discharged at the cathode? H plus ion will be getting discharged. Easy, no? In the same way, search for Cl minus and OH minus in electrochemical series. OH minus is over here and Cl minus is over here. Which ion is occupying at the lowest position? Lowest position is occupied by hydroxyl ion. So that will be getting more chance to get discharged at the anode. Clear, no? Now can you tell me, if you are electrolyzing a dilute solution of sodium chloride using inert electrode, which ion will be getting discharged at the cathode? H plus ion. What's the reason? The position of H plus ion is lower compared to that of Na plus ion in the electrochemical series. So write the cathode reaction. Who will be moving towards a cathode? H plus ion will be moving towards a cathode. It will be accepting electron from the cathode and will be getting discharged as hydrogen atom. Hydrogen atom cannot exist as such. It will be combining with one more hydrogen and hydrogen gas will be liberated. Now tell me, what will happen at the anode? Cl minus ion is there, OH minus ion is also there. So as per the position of the ions in the electrochemical series, who will be getting the chance to get discharged at the anode? OH minus ion. Okay, because that occupies a lower position. So what will be the reaction that is taking place at the anode? OH minus ion will be moving towards the anode. Whenever OH minus is moving towards the anode, remember 4 OH minus together will be moving. And see, can you see this one? See from this, 2 molecules of water will be separated, and what is remaining? 2 oxygen. That one together will become oxygen gas. Understood? So whenever OH minus ion is moving towards the anode, 4 OH minus ion will be moving towards the anode. It will be giving 4 electrons towards the anode and will be getting converted into 2 molecules of water and then 1 oxygen molecule. Okay, this oxygen gas will be liberated at the anode. Water will be retained in the electrolytic cell only. Got it, no? Now we are going to see the electrolysis of concentrated sodium chloride solution. So compared to dilute sodium chloride, concentrated sodium chloride solution will be containing more amount of sodium ion also, chloride ion also. That is a difference. So in order to predict the product obtained at the cathode and at the anode, we will have to first write what all ions are present in the solution. The positive ions Na plus and H plus ion is present in the electrolytic solution. And negative ions are Cl minus ion and then OH minus ion also. There is no difference at all. At a time, only one will be getting a chance to get discharged. Okay, so out of Na plus and H plus ion, which will be getting the chance? It depends upon the position of the ions in the electrochemical series we said. The ion that is occupying the lower position will be getting more chance to get discharged. So which ion will be moving towards a cathode? H plus ion will be moving towards a cathode. It will be accepting 1 electron from the cathode and will be getting discharged as a hydrogen atom, which in turn will combine with one more hydrogen atom and will be liberating as hydrogen gas. Now think about the anode reaction. Cl minus ion is present, OH minus ion is also present. So if we compare the electrochemical series, the position of Cl minus is over here and OH minus is over here. We are expecting OH minus ion to get discharged. But one problem is there. Okay, we are taking concentrated sodium chloride solution. In that, Cl minus ion concentration will be greater compared to that of OH minus ion. Or you can say that Cl minus ion present in the solution will be greater. So we will have to consider that factor also. Correct? No? Yeah, it not only depends upon the position of the ion in the electrochemical series, but it depends upon the relative concentration of ions also. So compared to electrochemical series, OH minus ion is getting the chance. But compared to the relative concentration of the ions, Cl minus will be the winner. Okay, write the anode reaction. What will happen at the anode? Cl minus ion will be moving towards the anode and it will be discharged as chlorine atom, which in turn will combine with one more chlorine atom and will be liberating as chlorine gas. So what will be the observation at the anode? Greenish yellow gas will be evolved at the anode, you should tell. Now one doubt will come to mind. If concentration of Cl minus ion is greater in this electrolytic solution, Na plus ion also will be greater, no? Then why H plus ion is getting a chance? Okay, how can we explain that? Sodium has the electronic configuration 281. When it becomes sodium ion, it is already attaining stability. Correct? No, one electron it will be missing. So already it is happy and staying as stable. Then see, if any other ion is present in the electrolytic solution, sodium will never go to that side, right? What's the reason? It has already attained stability by having the electronic configuration 2,8. So it doesn't want to accept one more electron. So that is the reason, even though Na plus ion concentration will be greater in the electrolytic solution, it will be giving a chance for H plus ion. Okay, you go and discharge, it will say. Okay. So remember, whenever concentrated sodium chloride is electrolyzed, what will be the observation at the cathode? Hydrogen gas will be liberated. What will be the observation at the anode? Chlorine gas will be liberated. You should memorize that. Now see the question. When dilute sodium chloride is electrolyzed using graphite electrode, the cation which is discharged at the cathode most readily. So if you are getting this kind of questions, had better we find out what all ions are present in the solution. As it is sodium chloride solution, Na plus ion will be present, H plus ion will be present, OH minus ion will be present and chloride ion also will be present. But they are asking which ion will be getting discharged at the cathode. So out of Na plus and H plus, which one will be getting more chance? H plus ion, because H plus ion has got a lower position in the electrochemical series. We explained that. Okay, we got the answer. Yes. See the next question. It is a very beautiful question. M2O is the oxide of a metal M, which is above hydrogen in the activity series. M2O, when dissolved in water, it forms corresponding hydroxide, which is a good conductor of electricity. State the reaction taking place at the cathode and name the product obtained at the anode they are asking. So already they said that M is a metal. Metal oxides are generally what in nature? They are generally basic in nature. Why they are basic in nature? Because when dissolved in water, this metal oxide will be giving corresponding hydroxides. And now they are telling, to this basic solution we are passing electricity. Now write and see, this is the cathode and this is the anode. So if you want to predict the product at the cathode and anode, what we need to do? We will have to write the ions present in that. It is an aqueous solution of metal hydroxide, MOH. Correct, no? So it will be containing metal ion, and in addition to that, as it is an aqueous solution, H plus ion also will be present in that. And which will be the negative ion or anion present in the solution? OH minus ion only. Okay, so we have written it, and now you will have to choose which ion will be getting a preference at the cathode, right? So for that they have given a clue already. This metal is above hydrogen, correct? No? In the activity series they are telling. So which will be getting a chance to get discharged? H plus ion. So that is the answer. Okay, write the cathode reaction. At the cathode what will happen? H plus ion will be moving towards the cathode. It will be accepting one electron and will be getting converted into H. H and H will combine together to form hydrogen gas. Okay, so hydrogen gas will be released at the cathode, you should write. We have written the reaction also. Now what will happen at the anode? There is no competition at all. Only OH minus ion is present. Whenever OH minus ion is getting discharged, how many will be getting discharged? 4 OH minus ion. It will be giving 4 electron to the anode and will be getting converted into 2H2O and then oxygen. Easy, no? So can you tell me which will be the product obtained at the anode? Yeah, that is oxygen gas. We answered all these questions. So it's so easy for you now. Within no time, you have learned the electrolysis of molten, concentrated and aqueous sodium chloride. Keep on working hard.